video. Today we will start the syllabus of B.Sc second Inorganic Chemistry. Now generally in case of B.Sc second Inorganic Chemistry, this consists of that is five topics. Now these are the five topics. First will be coordination chemistry. That is coordination chemistry can be taken. Second will be chelation. That is second will be chelation. Third will be study of P block elements. And fourth will be chemistry of 3D elements. And fifth will be semi-micro qualitative analysis. As per your syllabus here, fifth topic semi-micro qualitative analysis. This can be deleted for the syllabus. Only four topics can be taken. One is coordination chemistry, second will be chelation, third will be study of P block elements, fourth will be chemistry of the 3D elements. Now today we will start, that is the coordination chemistry as concerned to inorganic chemistry. Now generally coordination chemistry can be defined as, that is the study of the coordination compounds. That is any chemistry which can be deals with the study of coordination compounds. It is called as the coordination chemistry. Now in case of coordination chemistry, why this topic can be taken for the syllabus? Because today we know that the importance of the coordination compounds. That is the importance of coordination compounds. They can be taken in case of the medicines. If today you are seeing the medicines, in case of the medicines, tablets, syrups, they can be made up of the coordination compounds. Again, you should take here, that is for the isolation process. Isolation, again separations as concerned to metals. Here, coordination chemistry plays very important roles. Again, that is you can say so many branches of the totally today's life. Here, coordination compounds can become for the use as concerned to human beings. And therefore, the wide applications, the coordination chemistry is most important. And how this can be studied? This can be studied as concerned to the coordination compounds. Just I have told here that the branch of chemistry which deals with the study of coordination compounds, it is called as the coordination chemistry. Now again the coordination compounds. The coordination compounds can be defined as, you can say here that coordination compound can be defined as it is the central atom which is surrounded by the certain number of the, you can say, anions. Now in case of the anions can be taken, again you can say neutral molecules. Neutral molecules can be taken. Again positively charged, you can say ions can be taken. Now generally here that is the central metal atom which is surrounded by certain number of anions, means negatively charged particles. Again neutral molecules, again sometimes positively charged ions. As concerned to the central metal atom, such compounds are called as the coordination compounds. Now here the charge on the central metal atom, it is most important. Now generally the central metal atom, when we have taken the charge of the central metal atom, it can be associated with all the anions, all the positively charged, you can say ions. And therefore totally here coordination compound is most important. Now generally when once we know that the introductory part as concerned to coordination chemistry, we must know that the formation of coordinate bonds. What is the meaning of coordinate bond? Now coordinate bond can be taken here. If we have taken as a coordinate bond, now how the coordinate bond can be taken? Now coordinate bond, first of all this idea can be given by the scientist G.N. Lewis in 1916. That is 1916 can be taken. Again if we have taken Sidgwick scientist, he have studied in 1927 as concerned to the coordinate bonds, and therefore according to G.N. Lewis here, the coordinate bond can be defined as the pair of electrons which can be required for the bonding can be contributed by one atom only in case of the molecules. It is called as the coordinate bonds. Now generally suppose we have taken here that is A and B both the atoms. Here the two electrons can be required between the two atoms, and all these two electrons can be contributed by this atom A. It is called as the coordinate bonds. And the sharing can be taken by both the atoms, but the electrons contributed by only one atom, and hence it is called as the coordinate bonds. This coordinate bond can be indicated by the arrow. This arrow can be shifted from the donor atom to acceptor atom. Here A can be possesses lone pair of electrons, and therefore B can be possesses vacant orbitals, and therefore from A electrons can be shifted to B, and therefore in between the atom A and B, here this coordinate bond can be indicated by. This coordinate bond is also called as the dative bond. This is also part of the dative bond can be taken. It is also called as the co-ionic bond. Co-ionic bond can be taken. Sometimes it is also called as the semi-polar bonds. And therefore this covalent bond, that is coordinate bond, is also called as dative bond, co-ionic bond, semi-polar bonds. The peculiarity, the characteristic property of this coordinate bond is that among these two atoms, only one atom can be contributed by the two electrons in between the two atoms. Means here that is the atom A possesses two electrons, B is a vacant orbitals, and again here A can be contributed by the both electrons. Hence it is called as the coordinate bonds. So when we are taken as the coordinate bonds, generally what happens here? The conditions for formation of coordinate bond can be taken. Which are the conditions? When we have taken the definition, in case of definition, it can be tells that A and B both atoms are present. Means here two atoms are essential. Conditions for formation of coordinate bonds. First condition can be taken. Which is the first condition? Here atom A, which is called as the donor atom. Donor atom must possesses at least two electrons in case of its valency shell. Means here outermost orbital of the donor atom must possesses two electrons. It is called as the lone pair of electrons must be possessed by the donor atoms. And second condition can be taken. This atom B is called as the acceptor. This acceptor atom must possesses vacant orbital. Means outermost shell does not possess the electrons, it must be vacant. And third condition is that the donor atom must be able to donate the electrons to the vacant orbitals as concerned to acceptor, and this will be able to accept, this will be able to donate. Means the donor atom must be overlaps with the vacant orbital of the acceptor, so that electrons will be comes between the two atoms. This will be the third conditions. Overlapping is most important. Overlap is most important, so that both the electrons will be comes between the two atoms. Hence it is called as the third conditions. In this way, that is the conditions can be explained. Examples. Now here examples we are going to mention, that is first would be formation of NH3 and BF3. This will be called as the adduct. Again example will be formation of NH4 plus ions. Again next will be, we should take H3 plus O or H3O plus. These hydronium ions. This will be called as the ammonium ions. This will be NH3 BF3 adduct. Now we are going to explain one by one how the coordinate bond is present in case of these examples. First of all, you should take formation of NH3, again BF3. Now in case of NH3, that is the central atom. In case of NH3, that is central atom is nitrogen. Now this nitrogen possesses atomic number 7 and electronic configuration can be taken as nitrogen 7. This will be 1s2, again 2s2, here 2px1, 2py1, 2pz1. Means here totally this cell can be taken. That is, this nitrogen possesses here lone pair of electrons, means 2s2. Again 3 bond pairs, means here that is 3 hydrogen atoms can be attached. One electron as concerned to, you can say that is hydrogen, nitrogen, this will be taken. Now again here there is, we should take BF3. BF3 what happens? Boron can be having, boron possesses atomic number 5. 5 atomic number as concerned to boron will be electronic configuration 1s2 and again here 2s2, again 2p1, 2py. This idea can be taken. That is generally here there is 5 electrons can be taken. Among these 5 electrons, here 2 electrons can be taken. Not 2 electrons. We should take here that is bond pairs. 1 chlorine, 1 chlorine, second, this will be third, and this will be vacant. No electrons here. This idea can be taken, and therefore this electron can be transferred from nitrogen to borons. Means here we should take nitrogen, again borons. Here that is attachment will be taken. Means here that is nitrogen possesses lone pair of electrons. Boron is a vacant orbital. It can be accept the electrons. Here that is, this indicates as. Now here lone pair of electrons present between the nitrogen and boron. This can be also shown as nitro. You can say here that nitrogen F, again F, again here H and H. Now you can say also this will be taken as concerned to the diagrammatically. This will be the orbitals of the nitrogen. It can be possesses, but it possesses here one lone pair of electrons. Again this you can say here that here hydrogen can be attached. Here second hydrogen can be attached. Here third hydrogen can be attached. Again plus. Now when we have taken as the boron, this possesses vacant orbitals, and this will be chlorine. This will be second chlorine. This will be third chlorine, and this will be vacant orbitals. Now these two electrons, they will be comes in case of these orbitals. Means bonding can be takes place as like here nitrogen. Again here we should take boron. Here 2 electrons should be taken. This will be borons. We should take here that is attachment will be hydrogens. Here hydrogens. Here hydrogens. Again you should take here that is chlorine. Here chlorine. Here chlorine. 3 chlorine atoms will be present. Now in this way that is formation of NH3BF3 adduct can be takes place by the formation of this coordinate bond. This indicates as the coordinate bond is most important. So this is the first example. Now what happens in case of the second example? In case of the second example, you can take here that is in case of second example, formation of NH4 ions. This can be formed by taking of here hydrogens, here hydrogens, here hydrogens. Now we should take here that is lone pair of electrons plus. Again you should take here that is H plus can be taken. When you have taken H plus, no electron, vacant orbitals, and therefore you should take here that is here NH, again here H, here H, again here H can be taken. Now in this way plus charge will becomes, this charge will becomes on this whole molecules. Again you should explain here that is the nitrogen possesses lone pair of electrons. Here hydrogens are present. This H can be taken, here H can be taken, plus this will be, you can say, spherical vacant orbital, you can say H plus, and therefore totally what happens here, this is the nitrogen which can be possesses H, here H can be taken, again H can be taken, 3 hydrogen atoms, again lone pair of electrons which consist by this nitrogen, the overlapping can be takes place by these hydrogens, and therefore totally the whole plus charge will become on this complex, you can say, coordination compounds, and therefore in this way the formation of the molecule can takes place. Now again you should take here that is formation of, you can say, hydronium ions. How the H3 plus O can be formed, hydronium ion can be also formed by taking of water molecules plus H. Again you should take here that is water molecules can be taken. When you have taken water molecules, you should take here that is H plus H. When we have taken as oxygen, it is a central atom. Atomic number is 8. When we have taken 1s2 means this outermost shell consists of, here that is 2 lone pair of electrons. And these are the 2 bond pairs. 6 electrons will become 2 are bond pairs. Thus here we should take vacant orbital, you can say H plus. This idea can be taken here, that is, you can say here that you should take here that is O, you should take here that is lone pair of electrons can be taken. 2 lone pair of electrons will become. Now these 2 lone pair of electrons, they will be taken as concerned to, now see, this is the structures, but this H will be vacant orbitals, and therefore what happens here, this can be combined here H will becomes, and therefore totally what happens here, this whole charge will becomes on this complex, that is, you can say, now this diagrammatically represented as, this is the H3O plus, this will be H3O plus, and therefore you can say here that this is the oxygen, it can be possesses, you can say here that these are the 2 bond pairs of the 2 hydrogen atoms, you can say H, again here H, here lone pair of electron is present, here also lone pair of electron is present, and we will get as the vacant orbital H plus can be taken. This idea can be taken as concerned to this overlaps here, and therefore this possesses lone pair of electron here. Again this bonding can be takes place as concerned to lone pair H. Here bond pairs can be taken. This will be H, here this will be H. Now this is called as the plus charge will becomes. Now this lone pair of electron will be donated by this oxygen to the vacant hydrogen atoms, ions, and therefore totally formation of coordinate bond can be takes place. Now in this way, first of all you should take here that is, this will be indicated by coordinate bonds. It is here this oxygen is donor atom, this will be acceptor atoms, the bond can be shown between the oxygen to hydrogens. Now here also donor and acceptor will becomes. In this way coordinate bond can be explained as concerned to, you can say, coordination compounds. Now today we will stop here. Next lecture we will continue the difference between double salt and complex salt.